haven't even said anything yet. Come on, guys. So the slides are online there at my usual spot on talks.php.net. So I started this stuff over 20 years ago now, which is a long time. I started web development in 1993, and I wrote a lot of code that looked like this. I don't expect you to read it. Basically, writing web applications in C and running them as a CGI, which was quite annoying. There was a lot of C code, and you end up embedding a whole bunch of HTML inside your C, and it was just not a pleasant experience. So a lot of people started using Perl to do the same thing. It's shorter and easier to read, but it was still embedding HTML inside Perl, inside another language, which already in 1993, I wanted to get away from being the person that did the front-end look and feel. I wanted to hand that off to somebody else, and HTML editors were already starting to come out. So embedding HTML inside another language just wouldn't work, because then you couldn't separate the two roles in development. So I needed something that looked more like this, where I could go to the web developer and tell them, look, here are some special tags. So you've just learned HTML. Now, here are a couple of extra magical tags that will do interesting things for you. They didn't have to understand how they worked. They just had to understand what they did, essentially. So, very simple templating language, basically, with a little bit of logic and basically the ability to call functions and to have variables. And that was essentially the first version of PHP, looked something like this. It was written as a state machine, and it was terrible. As you just saw in this talk, JITs are hard. I didn't worry that much about writing a JIT or writing a language even. I was just writing a very simple templating system, and in order to solve a problem. And I focused mostly on the ecosystem. I focused sort of on the end-to-end solution as opposed to any one particular aspect of it. If I had started to figure out how to write a JIT, I would still be working on the JIT. And we wouldn't have anything written in PHP because I wouldn't be done yet. So I took a lot of shortcuts along the way, just to get to the point where, okay, I'm actually solving the problem. And let's solve the problem first, then figure out where we need to optimize the solution to basically get through any sort of sticky points or anything that stops certain people from solving the problem with the tool. And it's a very pragmatic approach. It ends up giving you a lot of ugly shortcuts as well along the way. For example, the first loop implementation in PHP was horrible. What I did was I would go through, I would parse through the code, and I would see the start of a loop, and I would pop the actual file pointer position. So did an ftell in C, if you speak a little bit of C, and I would pop that onto a stack. When I hit the end of the loop, I would pop that off the stack, and I would do an fseek back to the start of the loop and just keep going. So when people ask me, hey, loops are kind of slow, I would ask them, well, how fast is your hard drive? What's the seek time on your hard drive? And it's like, look, if you buy a faster hard drive that has better seek times, your loop will be faster, because the hard drive was actually seeking on every iteration through the loop. So after a while, I was like, well, this is probably not the best way of doing that, especially for stuff that looped a lot. But initially, I didn't even have any loops, right? I mean, I was writing a templating language, and loops aren't a super obvious thing in a templating language. After a while, when you start working with tables and things, like, oh yeah, okay, I'm going to need some loops here. So it's a very quick and dirty thing. And that was one of the examples of, okay, that was not the right way. Let's sit down and read a book and figure out a better way of implementing a loop. But there were a lot of things in PHP along the way where basically I learned just enough about a certain aspect of programming languages and parsers to solve the problem, but never more. I'm not a language geek. I don't really care about languages, which might be very disappointing for you guys, but I care about solving problems. And if I was a language geek, I would still be playing with my own little personal language. There are millions of people who have written languages out there that nobody has ever used because they're still playing with their language. They're not actually solving problems with it. So you need a lot of pragmatism to actually get something you write out there in the real world, because you can't solve every part of a problem in the perfect way. If you wait for perfection, you will never ever be done. And that's kind of been PHP's mantra over the years. Let's just fight through anything, any obstacle we get to, and let's just get to the solution. So, some of the things I was more focused on than the language design was, how do people actually run PHP? How do people put up a site on the web? And obviously in the 90s, everything was virtual hosts on ISPs. So you would buy a $25 a month virtual host slice somewhere, right? And it was just a virtual host in Apache most of the time. And you were sharing that same Apache instance with a whole bunch of other people. Sometimes thousands of people were on that same host. And PHP was available because I thought a little bit about this and said, okay, in order for an ISP to run something like PHP, what can I do to make their lives easier? So time limits, for example, being able to set the amount of time a PHP script is allowed to run. Memory limits. Say, okay, after a script has eaten up a certain amount of memory, kill it off. So some of these things were directly designed for ISPs to make them more comfortable providing PHP support to their users. This is something Mod Perl got completely wrong, for example. Mod Perl, when it came out a few years later, had very, very low-level access to the guts of Apache. You could write a Mod Perl script that changed everything about how that Apache server works. And for a standalone application, when you have your own server, perfect. You can do magical things with Mod Perl. But for an ISP to provide Mod Perl to its users, every user would have to have his own Apache instance. And especially in the 90s, that just wasn't feasible. You couldn't run thousands of individual Apache instances on a single server in any sort of cost-effective way, which meant that if someone wanted Mod Perl support, it would be 10 times or 100 times more expensive for an ISP to provide than PHP, which is why we don't see Mod Perl everywhere these days, right? Oops. I should have turned off my screensaver. So robustness as well was something I thought quite a bit about. Always stayed far, far away from threading, both at the web server level and in PHP as well. Humans aren't smart enough to write thread-safe code, as far as I'm concerned. And even if we are, there's always this little doubt. Was this some kind of threading race condition? When you take so many different third-party libraries that PHP links against, which is hundreds of libraries written by thousands of people out there, you put all this together and you expect it all to play nicely in a threaded application. When something goes wrong, you never quite know, hey, was this some kind of weird thread race condition, or is it a more pedestrian type of bug? And because you have this doubt, it just becomes really hard to debug. So I always avoided threads. And luckily, the way the web works, there's not a lot of reasons for having threads. I mean, you get full CPU and full core usage, multi-core usage, because you have concurrent requests coming into your web server. You don't need a single request to start lots of threads to efficiently use all your cores. Scaling as well. This idea of having a shared nothing architecture where every request is discrete and unique was, for scaling purposes, I didn't want to write an application server. There were other application servers coming out around that time, and there was always this issue of, okay, this application server, like application server variables in ASP, where you can stuff stuff into the application server, or in the JVM, you can store things directly in the JVM, which is very nice as long as your application runs on a single web server. But as soon as you have two web servers, and you've now stored something in the JVM or in the ASP engine itself, how do you then, when the next request comes in on a different web server, how do you share that? And I didn't want that to be my problem, basically. So with the shared nothing architecture in PHP, I punted and I said, okay, this is somebody else's problem. If you want a shared data store, go get one. Install Oracle, install MySQL, install Memcache these days. That wasn't around back then, but install some piece that will give you this shared data store. This is not my problem. Because of that, because of the shared nothing approach, and because I kind of just didn't want to even deal with that problem, PHP scales infinitely, horizontally. There's nothing in PHP that stops you from scaling. If it doesn't scale, it's your fault. It's not my fault. So the other thing that and when other people joined the project, we thought quite a bit about was scaling PHP down. As engineers and as geeks, we always think about scaling up, going faster, being more efficient. This last talk was all about pushing the upper edge of PHP to the point where Facebook can run their stuff 8 times faster, which is great, but that doesn't help the weekend warrior who's just getting started. He doesn't care about running stuff 8 times faster. He cares about actually being able to run something and it works, and not having to read 5 chapters of a book on Java to figure out how to print out a string, right? This idea of scaling down and actually making the language accessible is a huge, huge, important piece, especially when something is new. If the first thing you try in a language just works, then you get motivated. You get, hey, that was easy. What else can I do? And that was how PHP grew so fast. It came exactly at the right time, right as the web was exploding. And it provided something that was really easy to get started with. It just worked out of the box. It was available on all the ISPs in the world. And a lot of that was because we thought about, hey, how can we make this really, really accessible? So something like making variables automatically, form variables automatically become available in PHP. So you have a form. Input type equals name, and you get $name directly in PHP. Yeah, these days we probably don't need that anymore, but back then, that really, really helped. Getting PHP going and explaining to people how to write dynamic web applications. And the tricky part in PHP is pushing up to Wikipedia, Facebook, Yahoo levels, and also pushing down to the weekend warriors is tricky to do in a single code base. It's really, really hard. And that's where sort of the rocket science of PHP comes in. Whoa. I've confused it. Being able to have all that in the same code base, we had to make some concessions. And most of the criticism of PHP today comes from some of these concessions that we have made over the years. So, and some of them is just legacy, right? So case insensitive function names. In 1994-95, HTML was not lowercase. Well, some of it was. A lot of people wanted their HTML tags to be all uppercase. Some people even had mixed case, which was weird. But there was nobody had really standardized on lowercase HTML tags, and there was quite a religious argument back then of whether HTML tags should be upper or lowercase. And the first version of PHP basically tried to slide in and to look like HTML tags. So I didn't want to be part of this religious argument, and I basically said, well, you can have your PHP tags either upper or lowercase, it's fine, it'll work both ways. Plus, you shouldn't have a function name that only differs in case in your code anyway. That's silly, right? So that's where it came from. And yes, I probably should have changed it in about 1998 or so. But in 1998, there were already hundreds of thousands of servers out there running PHP. And it seemed like a lot of backward compatibility breakage, potentially, for very little gain. So a lot of these things, there was actually a logical reason at one point, where today, 20 plus years later, that logical reason gets lost in the ether. And then it's just, what were you thinking? You couldn't possibly have a reason for that. Well, you weren't around 20 years ago. It made sense back then. So naming inconsistencies, most of these are due to the fact that PHP is just a very thin layer on top of hundreds of libraries. And the naming of functions tend to match the underlying implementation. So that all the various database APIs, before we tried to fix that with PDO, they matched almost exactly function to function the underlying API. So if you look at the MySQL C API, the libmysql client API, it will look very familiar to you because it almost matches exactly what you see in PHP. And same with other things like string handling functions right out of libc, take their argument order from those libc. So if you do a man on string char, for example, on your Linux command line, you'll see that that looks exactly like the PHP version of the string char function. And you'll also find that, so the biggest complaint people usually have is this needle haystack that changes randomly, apparently. It's actually not random. All array functions are needle haystack. All string functions are haystack needle. And it's not random, it's consistent. It's just switched because the underlying functions that most of these functions were based off of have that argument order. What else? Dollar signs, honestly, that was just to make things easier implementation-wise, and also because we do a lot of string interpolation in PHP, putting variables inside quoted strings. And so you had to have something inside a quoted string to denote the variable. You can either put like braces on the front or the back, or you can just put a single character at the front saying, hey, here comes the string. The single character thing seemed easier to me. And then making that consistent throughout the language seemed pretty simple and obvious. Globals work a little differently in PHP than every other language. I still maintain, 20 years later, that PHP is the only language that does globals correctly. Inside, I spent so many hours and months in C-land fixing problems related to clobbering globals or inadvertently overriding a global variable. So if you have a huge code base and you happen to, over in this part of the code base, you assign a global variable to something, and then way over here, you have a function that uses a variable that you assume is a local variable, but because some other developer made a global variable over here with the same name, you are now affecting this other piece of code. That makes absolutely no sense. You should be very clear about whether or not a variable in a function is going to clobber a global, which is why in PHP you have to declare the fact, hey, this function is going to clobber this particular global. And it's quite easy then to figure out and go through your code and see, okay, here's where this global variable is being accessed or modified. And I still think PHP is the only language that really does that way. Register globals, I talked about. It was really good for the scaling down and getting PHP off the ground. Without register globals, I'm not sure we would be here today. People may argue that, but that was one of the big reasons for PHP's explosive growth in the early years. Magic quotes, yeah, that was me being lazy. When I added magic quotes, PHP only supported 2 databases, and both of them escaped things the same way. So it kind of made sense. Once other databases came and they didn't escape the same way, the magic quotes made no sense whatsoever. So other things I focused on was performance. I mean, one of the big reasons I started PHP was because CGI was just not very fast. So CGI are either written in C or in Perl, because you have to fork and exec on every request, especially on 1990s hardware, it just couldn't be made fast. So I needed some way of getting away from having to fork and exec on every request. So I needed to get my code, my actual web application, needed to basically live inside the web server. And obviously I didn't want to put my actual application code in the web server, so I put the template language in the web server. So I could just give the web server a bunch of templates, and it would, without having to fork and exec, it would run my code. So that's where mod PHP came from. Right? An Apache module that lives inside the web server. Originally, the very first version of PHP, well, the first version was CGI based, but the very next thing I did was I hacked up the web server called NCSA and put PHP inside NCSA. And then the Apache project started up. And the Apache project, the name Apache comes from a bunch of patches, basically, to NCSA. PHP was one of these patches to NCSA, so I was very involved in the early days of Apache, of helping get a decent API into Apache and roll a bunch of other modules as well. But the point was getting away from fork and exec, and that was all about improving the performance of things. Robustness, one of the early databases I worked with was called MiniSQL. This was before MySQL existed. MiniSQL, written by a guy named David Hughes in Australia, was a very simple little MySQL-like database. And MySQL actually copied the API. So the API for MiniSQL is what you see today in MySQL. And when MySQL came out, all I had to do was I search and replace in my code. I changed MSQL to MySQL _ and recompiled, and it just worked, which was pretty cool. But in this MiniSQL, there were no cursors like you have in Oracle. So if you did a select star from some table, and you didn't realize that table might have 1 million rows, you're sitting there waiting a while for all of those 1 million rows to get transferred across the socket to you. And your web application just stopped. And often, I mean, most of the time, your web application isn't going to show 1 million rows anyway. You're going to show the first 10, right? You're going to have some kind of paginated thing. But there was no way of getting the first 10 in MiniSQL. So in my stupid, pragmatic way, I said, okay, well, let's just tell it. Limit 10. Only give me the first 10 things. And this silly, pragmatic solution to it that works really, really well, in the early days got a lot of criticism. Because, oh, this is not ANSI SQL. Like, there's an ANSI standard for SQL? What the hell? I had never seen that. And I didn't think it existed because all the databases seemed to be doing their own things. So I didn't know there was a standard. But despite the fact that it goes completely against the ANSI standard, it has now been picked up by other databases, and it's quite, I mean, everyone in here probably knows about the limit clause. I mean, you probably use it all the time, but it didn't used to exist. So max execution time, I talked a little bit about that. So ISP-friendly features to make it easier for ISPs to kind of swallow PHP and provide that to their users. They weren't happy about it initially. They really weren't. Because it's tricky, allowing people to write code on your servers, especially having multiple people sitting next to each other writing code. And that's where safe mode, which was another rather failed thing in PHP, came along. If an ISP has 2 users sitting next to each other on a server running as the same user ID, there's very little that you can actually do to separate them. I tried with safe mode, and we tried as a team. But there are so many third-party libraries that do things that it just was no way we could ever make safe mode bulletproof. So a lot of security reports over the years have been safe mode related because we claim to be able to separate users, but we can't guarantee that 100%. So we've had a lot of security reports that are safe mode related that Yeah, okay, it's a little bit unfair because all the other languages didn't even attempt to do that. Because we attempted it, we get hit with tons and tons of security reports, which is fine. We shouldn't have tried, I guess. But so take those with a grain of salt. If you see some kind of CVE against PHP, if it says safe mode anywhere in it, you can ignore it. So, all right, let's get to the present day here. How many people in here are not on 5.4 yet? How many on 5.2? One person. Okay. 5.3? 5.4? Wow, okay, it's working. 5.5. Few brave souls. Okay. So, it was about half and half 5.3 and 5.4 it looked like. I'm going to try to convince all you 5.3 folks in the room. And the 1.5.2 in the back there, you shouldn't even be here. You should be home upgrading. So, all right, so for those of you who are not on 5.4 yet, we have a lot of performance improvements in 5.4. So there's a list here you can go through. Empty hashes, so empty arrays, if you're initializing stuff a lot to an empty array is much faster now. The silence operator is quite a bit faster. Hopefully you're not using that too much, but there are cases where it's handy. Much better memory handling. Fast CGI support and FPM support has improved greatly. If you're running Nginx, you really should be on 5.4 with the FPM. Much, much better. We have a built-in web server. Please don't use it in production, but it is handy to kick off just from the command line, PHP minus capital S, kick off a web server, and then you can hit, you can specify the port, and then you can hit that port, and it'll use that directory as your document root, which is very handy for quick tests. Most frameworks these days provide a way of running through PHP minus S, so you can start an entire Symfony instance, for example, directly from the command line and test things. And from a debugging perspective, for the core guys, it's very nice that we can kick up PHP in web server mode without having to debug our way all the way through Apache or other web servers. Traits, basically horizontal code reuse. There have probably been talks, you probably know all about traits already, but that's a new big feature in 5.4. Short array syntax, so you can just use square brackets, you don't need the array keyword anymore. Function array dereferencing, so if a function returns an array, you can dereference it on that call. Right? So here, fruits returns an array of apple, banana, orange. So if you echo fruits, square bracket 0, you get the first element of the returned array. Enclosures in 5.3, we hadn't quite figured out what to do with all of this. It was a little bit tricky. If you define a closure inside a method, inside a class, if that closure tries to access a private variable or private property of that class, if that closure is then called from outside of the class, so you return the closure, so you call a method in the class, it returns a closure, then outside the class you call that closure, should that closure have access to the private property of the originating class? And we argued a bit back and forth, and we didn't really come to a conclusion in 5.3, so we just didn't do anything. But in 5.4, we finally said, well, you're the idiot who wrote that closure inside the class. It had access to that variable at the time the closure is defined, so we'll just maintain the scope at the time of definition. So yes, you will have access to the private property when you call the closure, no matter where you call the closure from. The short print syntax, so bracket question mark equals, is now always available. Short tags don't have to be on. So if you have a templating system that relies on that, you no longer have to make sure that people turn on short tags. There's a new session object, which means there's 6 functions you have to define if you're doing a set session thing. Then you can just provide an object that implements those 6 methods and pass the object in. There's a callable type hint, so stuff that takes a closure. You can say this thing takes a callable. Much better support for Asian characters. And you can now also turn switch multi-byte mode on in the send engine at runtime instead of having to recompile. Some JSON improvements. So there's a JSON serializable interface. So if your class ends up getting, or if an object of yours gets put into JSON encode, if you have a JSON serialized method and you implement this interface, you can determine, or you can set how your object should be JSON-ified. We're now using MySQL ND, the MySQL native driver, everywhere. By default, you can still compile against libmysql client. The nice thing about the native driver, though, is it's a client library written specifically for PHP. So it uses the PHP memory manager. It allows you a few nifty things like asynchronous queries against MySQL. And the nice thing about using the memory manager is that with libmysql client, you would do a select against MySQL, and it would then malloc a block of memory in the client library for the result blob. Then from the PHP script, if you then did a fetch all, for example, we would then have to allocate a blob about the same size on the PHP side. But this was in the same process. So we basically had two copies of the entire result in memory because the client library was using malloc, we were using our own internal memory manager. With MySQL ND, as soon as you do the select, it ends up being allocated with the PHP memory manager. So we no longer need two copies of the result anymore. So you end up using less memory. Now, if you actually switch to 5.4 and use MySQL ND, it might look like you're using more memory. Because we're now using the PHP memory manager, the memory limit, whenever you do a MySQL query and you get a big result set, that memory counts against your memory limit. Whereas before, if you're only reading in one row at a time and throwing it away, you never had the entire blob in memory. What you did, it was malloc, but it wasn't being tracked by the PHP memory manager, right? So it didn't count against your limit. Now it counts against your limit. So technically, from an operating system level, we're using less memory in 5.4 now, but memory limit-wise, you might have to increase your memory limit when you upgrade to 5.4 because you have to account for the fact that this now has to fit inside your memory limit. So the memory limit is actually more accurate with this. So maybe to support binary notation, just like you can do 0x for hex, right? You can now do 0b for binary, and a couple other minor features as well in 5.4. Performance-wise, we'll talk about opcache in a bit, but PHP 5.3 plus APC, so this is actually from a couple of Etsy servers where I did an upgrade. So PHP 5.3 with APC versus PHP 5.4 with the new opcode cache. The green is 5.3, green and yellow is 5.3, blue and red is 5.4. And the first one here is user CPU. So just doing the upgrade, the user CPU dropped by about 15%. The next one is system CPU, dropped by about the same, 12% or so. Average memory usage per request dropped as well from like 24 down to about 19 megs per request for our code. And the most important one, the response time. So the PERC95 response time, the latency basically, the time between the request hitting the server and the first byte being returned, dropped by about 14-15% as well. So in our case, across the entire site, which is average for a lot of different types of requests, we dropped from, what is it, about 590 down to 481 or so milliseconds, which isn't super fast. I'd like to get that well down, but we have a lot of things where we go and off to Memcache and to MySQL and Redis, and there's all kinds of things in there that it's not something I can optimize with PHP. It's something I need to optimize architecturally, which most optimization of websites these days come down to the architecture, not necessarily how fast the language is. You can shave stuff off the language, but you usually have bigger wins from other things. So, if you're going to upgrade to 5.4, where are the pitfalls? So there are some in HTML special chars. One of the things that we did was switch the default charset to UTF-8, away from ISO 8859-1. These days, you really should be using UTF-8 as your default charset. If you're not, chances are there might be some security issues. There are weird and wonderful cross-site scripting attacks that rely on bad charset handling, where if you think you are running in ISO 8859-1, but users are actually submitting UTF-8, it kind of looks like it works, but the various filters and things will get all confused, so you really need to match it up, and it's really safer to run in UTF-8. You can still use 8859-1, but you have to specify that on the HTML special chars call and entities calls. We have a new array to string conversion notice. So everyone in here has probably ended up with the string array in their web browser, right? Capital A. And it's always a bug. I don't care what anyone says. If that's how you're trying to print out array, you're doing it wrong. Right? It's always a bug when you see the string array. So now there's a notice on it. So if you try to do it, you'll get this array to string conversion notice. And I thought this was a helpful little thing to help you debug your code, but it was amazing how many people complained that, hey, this broke my code. Really? So, yeah, if you see this, you know if you see a lot of these array to string conversion notices when you upgrade to 5.4, you need to have a serious look at your code because it's wrong, very wrong. The one thing that mostly gets people, the first one is easy enough. Yeah, okay, I'm trying to print out an array. Obviously, that's not going to work. Where people get confused are on some of the array functions that, for example, array diff. It takes two arrays, but it's very clearly documented to just do a single level diff. So it only does a diff on the first level of the array. If you have nested arrays, you're going to have to do your own recursive array diff. So what happens is it flattens those. So if you have a nested array and you pass it to array diff, it's going to flatten it to be a single level. So it's going to cast this thing. If you have an array, it's going to get cast to a string. So in this case, if I'm doing array diff on an array that has 1, 2, 3, and the second array has 1, 2, but the third element is a nested array containing 3, this is going to get turned into the string array at that point, and which is why you get a notice. Now, if you're comparing two nested arrays like that, they're going to match because the third element is going to say array, and the third element is going to say array, and the other one as well, and it's going to say, hey, that matches, that's fine. But it's not actually checking the contents. And I think it was Drupal that had a lot of test cases that worked like that, where they were doing array diffs, where they assumed that they was doing a recursive diff, but it wasn't. And as soon as we added this notice, all their tests started failing because they had made this bad assumption. All right, so register globals, completely removed in 5.4 now. So if you're still relying on register globals, you're going to have to do some extract magic to get around that. Magic codes are now completely gone. We've also removed variable break continues, meaning if you did a break to a variable, or you did a break with the level, the number of break levels to break was a variable, that's not going to work anymore. I've personally never seen any code that had variable break levels like that, but if you have it, you'll have to fix it. Max input vars was the thing we added to fix the hash collision attacks that we've been seeing. So PHP uses a very simple hash algorithm that's pretty easy to game if you really want to. And what happens is if you structure a whole bunch of post variables or get variables exactly correctly, you name them correctly so that they will hash to the same hash bucket using PHP's hashing algorithm, you end up creating an array, like the post array, for example, where everything hashes to the same bucket, and if two things end up hashing to the same bucket, we just create a linked list. And usually that's not a problem. If we have decent distribution across our hash, Yeah, you might have a few buckets that have 2 or 3 elements in it, not a big issue. If you have 1,000,000 elements that all hash to the same bucket, then you end up, every time you need to add another one, you need to jump through 1,000,000 symlinks to add the next one, and then 1,000,001, 1,000,002 to get to the next one. And it takes forever, and you can DOS your server that way. So we set this high watermark and say, okay, well, no one's going to have more than 1,000 get variables or more than 1,000 form elements. Right? If you have a form with more than 1,000 fields, who the hell is going to fill out that many fields? Right? We figured out that should be safe. Even 100 should be fine, but let's up it 1 order of magnitude to 1,000. And of course, that breaks things. The PayPal IPN, the instant payment notification from PayPal, if you have a lot of things in your cart, when they send this post request with the payment notification, each item in the cart has like a ton of fields, and they come in a single post request, and that can easily go over 1,000. So if you have an instant payment notification endpoint, you may want to increase your max input bars for that particular endpoint. You can set it specifically in your configuration, obviously, or you can just jack it up to 10,000 or 100,000. 100,000, you start maybe noticing that people can DOS your server a little bit. At 10,000 and below, it's fine. Computers are pretty fast at going through symlinks. Some new reserved words. So if you have methods, functions named callable instead of or trait, you're going to have to rename them. Extending an abstract constructor, we changed slightly. Stream select is different. So a few very minor things that might hit you. For the most part, you shouldn't have a problem. If you're using tiger hashes as your passwords, you're screwed. The tiger hash was just wrong, and the original author of tiger hash has fixed it, but then all the old hashed passwords are going to hash differently now. If you actually are doing that, which I've never met anyone who is, but if you actually are, look at bug 61307 in the PHP bug database for a workaround of how you can solve this and convert your hashes over. All right, so hopefully that convinces you guys you should get on 5.4 soon. And for 5.5, we have a few more performance improvements, not as drastic as 5.4 at the language level, but the big improvement is we have now finally bundled an opcode cache. So PHP 5.5 comes with the opcache, which was originally the send optimizer plus cache. And it finally sort of fixes this schism we had in the PHP world where we had 5 or 6 different opcode caches out there. Some of them ran better with other things than some. And there aren't that many people in the world that can actually write an opcode cache for PHP. And having all those people working on different opcode caches was not a great idea. So we've tried to now say, okay, we're going to stick with this one opcode cache. Let's just focus all development on this. It also means when a new version of PHP comes out, opcode caching is solid from the first release, or hopefully solid from the first release, as opposed to before we had to wait 6 months before APC caught up to the latest version of PHP. The big new feature, one of the big new features is generators. So you can now create a function like this. You can put a yield. So the yield will basically return the value at that point and keep the state. So every time you call the function, it's going to return the next value for $I in this case. We also have finally. So if you want something that always gets executed in a try-catch, so even if an exception does occur, if you still want to call some kind of cleanup code, you can put a finally block on the end of it. You can put a list in your for each now to do the first dereferencing of an array. Not a huge deal, but it might be useful. Const array string dereferencing. I'm not sure why you would ever do this, but it was a bit of an inconsistency that you could do it with variables, but you couldn't do it with constant strings and variables, constant strings and arrays. You can also now call empty directly on functions and expressions. Before, empty always had to take a variable. You have to put stuff in and into a variable before you can do it. Now you can say, okay, is the return from this function, is it empty, according to PHP's empty definition. The curl upload functionality was a bit of a mess. You had to use an ampersand with a file name, and it was really weird how it was implemented. So we sat down, well, Stas sat down and rewrote it and made it work better. We also have a simplified hashing API. One of the themes we've seen over the past 5-10 years is that nobody seems to know how to hash passwords correctly. You keep reading about stories of sites that store their passwords either unencrypted in their database, or sometimes they just CRC them or MD5 them, right? Which is nowhere near sufficient these days. With rainbow tables and all the things you can do to break passwords, you have to actually use some decent hashing and salts against it. And all this stuff was available in PHP, but you had to know what you're doing, which kind of goes against the mantra of PHP is make stuff simpler. Even the complex stuff should be simple in PHP. And this, one of the few features in the last couple of versions that actually goes back to the original intent of PHP, is to make complicated things simple enough for ordinary people to do correctly. So this is one of those things. In 5.6, we're going to apply the same thing to SSL and crypto things and cert validation. There's some good work going on to fix that as well, because this is also something that's pretty complicated. Yes, you can do it in PHP, but you have to know what you're doing in order to make sure if you're connecting to an SSL site, are you actually checking the certificate that this is the right one, so that you are protected against man-in-the-middle attacks and things like that. So I'm glad to see some of this work is returning back to this original intent of PHP, is to make this stuff simple for people. All right. So another thing that changes a little bit with 5.5 because of this new opcode cache is deploys. Basically, nobody gets deploys right, as far as I'm concerned. When you're deploying new code to your production servers, what do? I mean, there are many ways of doing it. I know Facebook ends up taking entire banks of servers out of their load balancer, updating the code, restarting all the stuff on it, and then putting them back into the load balancer, which is correct and proper, and that's fine. But there's a lot of work. And if you're not Facebook, you don't have thousands of servers, it might not, if you have 3 servers, it might not be great to take out a third of your servers in order to upgrade that one server. And it's also slow. So you want to be able to just push code to production and just have it work without breaking anything. This is one of the things I did recently at Etsy. And there's few rules that you need to make sure you don't do, right? Don't just overwrite files in your current active document root, because you have requests that are happening that are reading these files. If suddenly the file changes, weird stuff starts to happen. So even if you're atomically changing those files, you can only do an atomic change on a file-by-file basis. You can't atomically change all the files in the directory in that same directory. So in order to solve this problem, you have to let all the requests finish on the old code and only start new requests on the new code. So you need at least 2 document root directories, right? So when you push your production code, the new production version, you push it to a new directory, and then you swap it, basically. So you have 2 document root directories. You have a symlink that points to the one that's currently active. And what you can then do is at the beginning of the request, you can check the symlink. You can see, what is my active document root directory? And from then on, make sure you always use that directory. Even if the symlink changes halfway through the request, because you only check the symlink at the beginning of the request, it shouldn't matter. And that was basically my solution at Etsy. And instead of having to do this in PHP, you can do it in PHP. If you always have a front controller, if you have a piece of PHP code that's always run first in your application, you could do it all in PHP land if you like. The only problem there is that particular script. But if you don't make too many changes to this little tiny bootstrap script, you're fine most of the time. But what I did was I wrote a little Apache module called mod_real_doc that does this real path. As the request comes in, it does a real path on that symlink, and it sets the document root as if you had configured the document root to be this particular directory. Right? So halfway through the request, you push a new version of your code, and all new requests at that point will now do that symlink check and do the read real path, and now get the other directory. So all new requests will now go on the new code. So you're going to have old code executing at the same time as the new code. And that way you can just continuously push new versions. And I ended up just flipping between the two document roots. Instead of making new document root directories, I flipped between them so that my opcode cache wouldn't get invalidated. So if you don't change a file across two pushes, then you can still use the compiled version that's sitting in your cache, which makes things memory-wise a little bit easier and faster. If you're not running Apache, Nginx actually has this feature built in. There's this magical real path underscore that you can add to things. So you can set your document root to $real path underscore root, and it will then real path that symlink, and your document root will be set to the target of the symlink, which is pretty cool. The one thing I don't think Nginx does, I don't think it caches that real path call. So that's the only thing different really in my Apache implementation, is that I have a little cache, and you can configure how long to cache that real path call, so you don't do it on every single request. I think Nginx ends up doing it per request. But we have the author in the room, so he might fix that.
Yeah, per request.
It's per request, right? But it would be possible to add some kind of cache to that, wouldn't it? No? It's just a configuration thing that says don't do it every request. Anyway, in most cases the real path isn't that super expensive. Unless you're on NFS or something, then it's terrible. Absolutely terrible to do a real path on every request. But in most cases it's not too bad. The only other thing you have to watch out for is you have to make sure that your code doesn't explicitly use the symlink path, right? So we had this var www site that points to either A or B. If you have code that explicitly does something include /var www site /something, it's going to use the symlink in the middle of the request. You want to make sure you don't do that, right? You want to make sure every include is relative, or it's using the include path that you have configured. So I wrote another little thing. It's actually a little PHP extension that will fix your include paths. So if you have var www site in your include path, it'll actually change it dynamically and set it to either A or B. It'll do the symlink, set it to the symlink target, so you don't have to worry about it. So you can, with these two, with the PHP extension and the Apache module, without changing any of your code in your application, unless you have other explicit includes, you can turn it into a very, very safe atomic deploy target where you can just keep pushing without restarting your web server, without touching your load balancer, without blowing up your opcode cache. At Etsy, we push new production code about 40 times a day, like full production pushes. We do another maybe 50, 60 config pushes. So most things in our code is very config driven. So we can ramp up experiments, or we can turn features on and off with feature flags, and we just need to do a very simple config push to change these features. So because we're pushing 100 plus times a day, we have to be really, really confident that a push does not adversely affect our production servers. And with this deploy mechanism, we can push all we want, and it really doesn't hurt. We can do very simple one-character pushes and push to production, and that's fine. We don't have to wait until production push Thursday, right? Which a lot of companies do. They have one push a week, which is not great for continuous integration approaches. So, if you're not on 5.3 yet, like I said, go home and upgrade. You should get onto 5.4 soon, if not 5.5. There are cool things in 5.5 with the new opcache. I showed you on the performance graph, PHP 5.4 can work with opcache as well. So PHP 5.4 and 5.5 with opcache is quite a bit faster than 5.3 plus APC, if that's what you're using today. If you're running PHP without an opcode cache, then you're going to have a happy day soon when you upgrade to 5.5 with opcache, because it's going to make things quite a bit faster. There are migration instructions at these URLs. So 5.2 to 5.3, 5.3 to 5.4, 5.4 to 5.5, that has a list of all these things that I talked about and many more that you need to know that could possibly trip you out with those upgrades. Most of them are very strange edge cases, but there may be one or two things that affect you. All right. I don't know what time it is. Okay. Good time. Questions?